Welcome to another episode from our chemistry videos. Today we'll be discussing stoichiometry. Now the question is, what is stoichiometry? Now many believe stoichiometry is just anything that has to do with chemistry calculations. No. For instance, when we combine hydrogen and oxygen, chemical reaction occurs and something new is formed. That substance is water, like we know. Now, this process is called chemical reaction. Chemical reaction is therefore the conversion of reactants molecules to product molecules. It is a process by which reactant molecules are converted to product molecules. Now we can represent this combination, this reaction, with an equation which we call the balance equation of the reaction. But this reaction here is not yet balanced. In order to balance, we have to make an atomic count. Here we have 2 hydrogen. On the product side, we have 2 hydrogen atoms. Then on the reactant side, we have 2 oxygen atoms, which make up 1 oxygen molecule. But here we have just 1 oxygen atom, so we have to balance the oxygen. Doing that, we will definitely need a 2 here. And here it's now balanced, but these 2 has already affected the hydrogen, so therefore we can say in order to balance hydrogen, 2 times 2 is now 4 hydrogen here, whereas here we still have 2 hydrogen, so we just need to put a 2 here. Now the word stoichiometry comes into play when we look at the quantity of reactants and products formed. Quantity of reactants used, the quantity of product formed. So therefore we can say stoichiometry is a quantitative study of the reactants and products in a given chemical reaction with respect to the balance equation of the reaction. Here it can be interpreted here that 1 mole of hydrogen, 2 moles of hydrogen, Y, the coefficient in front here is 2, combined with 1 mole of oxygen molecules to give us here to produce 2 moles of water molecule. So in order for us to solve any problem, any question that has to do with stoichiometry, it means we still have to bring in the mole method, the expression we derived last time in our mole concept videos. That is to say, 1 mole of any substance equals or contains 6.02 times 10 raised to power 23 particles as molecules of that substance. And if it's a gas, at STP, this will equal or contain a volume of 22.4 dm cube. And these will contain a mass. The mass of this 1 mole, like we said last time, is 1 molar mass, or 1 formula mass, molar mass. So therefore, knowing this, we can apply these in solving some questions. Now let's quickly solve one question and see how this will definitely help us. Now in order to solve this question, what volume of hydrogen gas is liberated when 2.3 grams of sodium metal is completely dissolved in water? Now the first thing we have to do is to simply write the balance equation of reaction. Sodium metal dissolves in water. This will obviously produce the base sodium hydroxide, and at the same time hydrogen gas liberated. Now, having written that, we obviously have to balance the equation. Let's check if the equation is balanced. Sodium here on the reactant side is 1, sodium on the product side is 1, hydrogen is 2, hydrogen is 3. So we have to balance this by bringing it 2 here, Now I have hydrogen as 4, oxygen as 2, so I will need an extra 2 here, balancing both oxygen and hydrogen. Now I will need a 2 here to balance sodium. Now, looking at the question very well, they make mention of sodium, and sodium here was mass, so gram here. Then they asked for volume here, volume, that's gram against dm cube. Now we have to interpret this equation to suit it here. So here we'll have 2 moles of this guy, 2 moles of sodium, giving us 1 mole of hydrogen gas. So we just have to draw from this linear expression. In order for us to solve this, we have to draw the relationship between this value here, which is mole, and what is given, gram. The relationship between mole and mass here is 1 mole equal 1 molar mass. So we can draw this relationship of mole and mass, converting mole and mass. We can say mole equal mass over molar mass. So means mass becomes mole times molar mass. And in order to do this, we simply have to bring the molar mass here. The molar mass of sodium we know is obviously 23 grams per mole. And here we cannot bring molar mass here, but rather they ask for volume. The relationship between mole and volume is 1 mole equal 22.4 dm cube. So we can simply bring in the gaseous molar volume here. That's 22.4 dm cube for 1 mole. That's dm cube per mole. Now, in order to make it suit it here, we know that mole equal mass over molar mass. We know that mole equal mass. In order to convert molar mass to mass, we would have to simply multiply mole and molar mass. That is to say 2 moles times 23. This should give me 46 grams per mole. Will cancel mole per mole, will cancel mole. So in this equation, 46 grams, which is 2 mole of sodium, is reacting here, and that produces 1 times this, which is 22.4 dm cube of hydrogen gas. Now we can now bring in the question, because the value here, the unit here agrees with the unit in the question, and the unit here now agrees with the desired unit, which is volume. So therefore means if this produces this, then this should 22.3 grams, 22.3 grams, 22.3 grams should produce X. So if this gives this, and this should give X, and cross multiplying, X becomes 2.3 grams of sodium metal times 22.4 dm cube of H2 divide by 46 grams sodium metal. Grams of sodium cancels grams of sodium. That should give us a 1 point, total of 1.12 dm cube of hydrogen gas, which is this unit left here. Now, having discussed this, in my next video we're going to solve more questions using this same values from the mole concept. Remember to share and subscribe and join us in our next video. Thank you.